Okay, so for this question, it's a paired difference question. They told me that it is, but if I didn't know this, what I got to pay attention to is that you see how this is kind of coming from. So I've got an older brother, younger brother. So those are groups from the same family, and you might think, is one family is if you have one family. Trust me, teaching high school for so long, just because one sibling is sharp right on doesn't mean the other one is, but they tend to they tend to. I mean, you got all that support come from home. They get the resources to help the kid out. It tends to be a relationship. These are not independent samples. So that's one way you can determine that if in case they didn't if they didn't tell you there's a pair difference. So because it's a pair difference, we're going to find the differences, and we want to test. Let's see, how do they word it? I want to make sure I do this right. It's not the mean difference. It's the mean difference, not the difference between the means, right? We're testing the mean difference versus the difference in the means, because these are the same. We say, is the difference in the means equal to zero? Sometimes it's not equal to zero. Usually it is. Okay, so let's come back here. So what we're going to test is, let's see, let me get my board going here. What we're going to test is HO. So this is the claim. Let's say to identify the claim that the elder siblings have a higher IQ than younger siblings. So HO, we're going to say the mean difference is equal to zero. There's no difference between these two. They're the same IQ. But what the claim is that actually the mean difference, older minus younger, will be greater than zero, will be positive. So that's what we're testing. I'm not going to, I've identified the claim. Well, I mischecked the conditions. Sample size is a little small. IQ tends to be normally distributed. I think we're okay to use the test. So we got our HO. I'm going to go out and use that Rossman chance applet. Before I leave this screen, I'm going to write down some numbers here. Let's see. I need to write down. Let's see. For one, the older brother, the mean is 100.7, and the standard deviation is 12.2. And I look at the differences. I'm glad I made that mistake. So because this is a mean difference, we need to look at the differences. We're going to do this as a one sample t-test. So the mean difference is 2.5 and the standard deviation is 3.5. I'm looking at these numbers, not those numbers, okay? Because if you're trying to use those, you're going to treat it like it's a two sample t-test. This is a one sample test, but we just do with a mean. So now I'm going to come back here to a Rossman chance applet. And before I leave this page, I'm going to go one mean. I'm going to make it a right tail test good. So now I can lose those. I'm going to lose that writing because we've got the HO and HA. And we know N is, I didn't write down N. Was it 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. And of course, they told us 10. Oh, yeah. Okay. Should read the problem. 10. The mean difference is 2.5. And the standard deviation of all those differences is 3.5. Now this will do the standard error calculation for us. You don't have to worry anything about that. So there's my test statistic. There's my p-value. What do they want us to do with this question? Test the claim at the 1% level. Well, that is at the 1% level. Okay, at the 1% level, this p-value is bigger than 1%. So we're going to fail to reject HO. We can't say the data doesn't support the claim that older brothers have a higher IQ on average than the younger brothers. Okay, and then even at the 5% level, that p-value is bigger than 5%. So we fail to reject that also. All right, so in the actual involved 10,000 milliseconds without having the actual spec on whether you could support the claim at the 1% level. Well, It's not a random sample. It doesn't, does it tell us they're a random sample? I'm wondering, what does Dr. Stevens say? Do I still have that document open? I'm thinking my only, it's a big sample. I mean, that's a big, so you could almost say, boy, based on that many results, maybe there's something going on. However, it's not a random sample. So to say that, oh, here we go. Let's come back here and look at this. Let's see. He says, since we don't have the standard deviation differences, we don't know for sure what the test statistic will be. I would assume the standard deviation sample will get a test statistic of, regardless of level of significance, this will end up in the rejection region. So it's a pretty small standard deviation. Okay. So he doesn't take into account anything about random samples or not. I guess that's not what he was thinking about. And then this part, let's see, notice the eye. What was the question? The question was, whoops. The question was, what other patterns discernible just from the small sample of data we've given? I'd like to see a picture of this data, but I'd like to see it like a dot plot. I don't want to take the time to do that. Let's see what Dr. Stevens says. He says IQ is given lowest to highest for the older brothers. Score the younger brothers also in this direction. As such, there seems to be a correlation between the IQs of the brothers. Okay, and we'll see if that, well, see, that would make, see, this is just going in, yeah, I don't know quite why he's doing that, but this is just going into that whole idea that, yes, these are dependent samples. Okay, so I don't know, I guess that's what we'll go with. That's what he said, he's the boss. Okay, but that's how you run these one sample t-tests. That you just work with the differences and then just use one mean. If they're independent, then you want to go with two means, you use both groups. Okay, hopefully this helps you do this kind of problem when you hit to the WebAssign one. Or even, if you want, what would make a great post in the discussion forum would be to post this foot length one. Okay, you can do the same kind of work and show the picture.